Hi everyone, our group is gonna present on the demand forecasting analysis of Pronto Cycle Share, a public bicycle sharing company based in Seattle, Washington. In the next 5 minutes, we will go over the following fields. So these days, the increasing concern on sustainability pushes people to think more about our life in the ecological environment. As one of the results, the idea of bike sharing rises and brings a revolution to daily commute transportation, which is not only healthier but also produces less pollution. For share bike providers, the most critical problem becomes how to balance the limited supply and the fluctuating demand so that they can better determine bike distribution and maximize bike usage and profits. We use data of Pronto Cycle Share to further analyze this problem. The goal of this project is to provide guidance to Pronto's demand forecasting. It can potentially contribute to the decisions in subsequent steps, like setting up new stations, pricing strategies, and so on. The long-term effects will be an increase in efficiency of the system and an enhancement of the company competitiveness. Same analysis can be applied to other share bank companies.
Here's the variables we decided to include in the model, which are demand, station, date and time, and a couple of weather indicators. Now let's walk through our data pre-processing process. This is the data that we download from Pronto's websites. Next, we need to scrape hourly temperature, humidity, visibility, wind speed records from timeanddate.com using Python with packages including requests, Selenium, and pandas via the website's HTML tags and save it as a CSV file. Then we turn the hourly data into 4-hour data. It means 6 time slots per day for the both trip and weather records. For the weather records, all the other variables are calculated as a mean of a corresponding time slots. We then add a binary variable weekend to the dataset. Then we add a new variable demand to the trip data as a total number of records of each station each day of each time period. Assume that is the demand.
In order to integrate all features in one file, we use Panda to merge the two tables. However, we found out that there are too many stations, so we decided to locate the stations on Google Maps and found out that for those stations names started with the same letters are close to each other. So we categorized those stations together and then add up the demand for those stations using group by function in R. That's the end of our data pre-processing process. Then we randomly split our data into training and testing set with a 9:1 ratio. We first fit a linear regression model to get a sense of how a baseline model works for our dataset. Then we train it with cross-validation CORDS model, bagging, basic random forest, and cross-validation random forest. At the end, we also try a boosting model as well. From the results of all models, we can see that the best OSR squared and RMSE are from cross-validation random forest model, but the best MAE is from basic random forest model. For some reasons, the boosting model gives us a negative OSR square. It might indicate a sign for overfitting, so we do not consider boosting at this point.
Based on the results, we choose random forest with cross-validation to be our prediction model. Future demand can be predicted with this model, and bikes should be distributed to proper stations in advance. In addition, we could identify under what conditions does a station more likely to reach its full capacity, and use dynamic pricing strategy to direct demand between different stations during different time slots. More popular stations and more busy time slots will have higher prices. We do realize there are some limitations in our analysis. First of all, business operations could be very different in different cities or countries, so our analysis may not be directly applied to other companies. Secondly, we are assuming number of records to be equal to the actual demand, which is not necessarily true. Lost demand is not checked, but if a particular station reaches its full capacity, we can assume a certain percentage of lost demand. Last but not least, weather forecasting is not 100% certain, so using weather conditions as variables will result in more variance. Thanks for listening. We are willing to reply any question you may have through email.